Hello, j'espère que vous allez tous très bien. Dans cette vidéo, nous allons faire cet exercice d'électrostatique. Probablement que vous l'avez fait en salle. Ok? Donc je vais le reprendre ici très simplement. La petite surprise, c'est qu'on va le faire un peu en anglais. Parce que vous êtes des scientifiques. Vous faites l'anglais scientifique. C'est important de parler l'anglais, n'est-ce pas? So, without further ado, the exercise is what? I give you a vector f of or a field of vector, okay, defined by f equal to x ux minus 2y z squared uy minus 2z y squared plus a constant c. The first question is f derives from a potential? Is the first question. Est-ce que f dérive-t-il d'un potentiel? Okay, so to answer this question, what is the method? First, I will determine the first component of f, the second, and the third. What is the first component of f? Is fx. The second, fy, and the third, fz. Forget this constancy, okay? Is an error. Okay, so here I have fx equal to x, okay? Fy equal negative 2yz squared, and finally fz, which is negative 2zy squared. So what is the method to know if f derives from a potential? The method is very simple. You take fx, you take fs, and you derivate it with respect to y. So I take the derivative of fs with respect to y, for example. So here is y, which is the variable. When I thought that I will derivate fs with respect to y, is y the variable. So s is a constant here. So the derivative is 0, right? And I will take also fy. I will calculate the derivative of fy with respect to x also. Okay? Do you notice how I take these two derivatives? I take s and y. Derivative of fs with respect to y, and the derivative of fy with respect to s. Okay? So you take s and y. Okay? So what is the derivative? Notice that in the expression of fy, we don't have x. So when I say that I derivate fy with respect to s, is like s is the variable. Okay, s is the variable, but here I don't have x, so the derivative is 0. Okay, so you notice that these two derivatives are equal. The derivative of fs with respect to y is equal to the derivative of fy with respect to x. Fantastic. If you comprehend it, is okay. Ok, je vais en français. Quand vous prenez en fait le fx et fy, vous prenez fx et fy, vous dérivez fx par rapport à y, et vous prenez fy, vous dérivez par rapport à x. Quand ils sont les mêmes, c'est super. Vous devez continuer. Regardez, j'ai pris pour ce faire, j'ai pris x et y. Ok, maintenant je pouvais prendre x et z, vous voyez, et aussi y et z. Donc il y a en fait trois choses à vérifier ici. Donc quand l'égalité elle est bonne, je continue. Mais notez bien, si l'égalité n'était pas vérifiée, j'allais m'arrêter et dire en même temps que f ne dérive pas d'un potentiel. So, we have to have three equalities. Okay? The first one is this. I will take also, okay, s and z, and to finish y and z. Okay? And I will verify this kind of equality. So, let's take s and what? Let's take s and z. Okay, so I will derivate fs with respect to z. The derivative of fs with respect to z equals what? You know, in the expression of fs, we don't have z, so the derivative is 0, and I will calculate also the derivative of fz with respect to x. Okay, we don't have s in the expression of of fz, we don't have x, so the derivative is also 0, and I can conclude that these two derivatives are equals. Okay, the derivative of fs with respect to z equals the derivative of fz with respect to x. Okay, so I have the second equality. So it has one equality. I take already s and y, s and z. To finish is y and z. Are you okay with me? Great. So I will calculate the derivative of fy with respect to z, for example. So if I take fy, see the expression of fy. I have negative 2yz squared. I will derivate, excuse me, fy with respect to z, and I obtain what? Z is the variable here. So z squared, what is the derivative of z squared? This z squared, if I derivate it, I will obtain 2z, okay? Because is z the variable here. So the result is negative 4yz, okay? Now I will take the derivative of fz with respect to y, okay? Fz with respect to y. Is y the variable? So the derivative of y squared with respect to y is 2y, and so the derivative of fz with respect to y is negative 4yz. And you see, fantastic, amazing, these two derivatives are equal also, okay? So I have also the final equality, okay, expected. So the derivative of fy with respect to z equal also the derivative of fz with respect to y. I have so the third equality. Three equalities are verified. I can conclude that f derives from a potential. Okay, so we can conclude that f derivates from a potential v, from a potential v. Okay, the potential is called here v. This means what exactly? This means that f is equal to negative gradient of the potential v. So the second question here is to determine the potential. How to determine the potential? This question is difficult usually for students, but I will try to explain it for you very simply. Okay, so I will take the second question. The second question is to compute or to calculate v. Okay, how? You have to know the expression of the gradient of a scalar function v. What is the gradient of v? Very simple. The gradient of v, okay, is a vector with three components. Okay, the first component is the derivative of v with respect to s. So the second is the derivative of v with respect to y, and the final one is the derivative of v with respect to z. So the gradient wrap up in a certain sense the three derivatives of the function. If I can put it like that. Okay, so the vector f is equal, like I said it previously, okay, f is equal to negative gradient of v, right? So I can say that f has three components: fx, okay, fy, and fz. That is the vector f. This vector is equal to negative gradient of v, so negative the expression above, right? Okay, so I copy and I paste it here. The beautiful, or the the most beautiful invention in the world, copy and paste. It's very good. So I have a system of equations by identifying the components. So I can identify fx with this, fy with this, and fz to finish with the last one. So I have three equalities. Fx equals negative derivative of v with respect to x. Fy equals negative derivative of v with respect to y, and to finish fz, which is equal to the derivative or negative derivative of v with respect to z. Are you okay with that? Take a deep breath and try to comprehend everything we did already. Okay, you can take a pause of or a break of 5 minutes. This is not a problem. Okay, you can make a pause because I comprehend that it's difficult to understand. It can be very abstract for the first time, but we're gonna do it. Okay, very good. So what is my goal here? What is the goal? What is our goal? Our goal is to find the potential v. This is our goal. Okay, so you know, when the variable or the inconnu, well, the unknown variable is v, I want to have this at the left of the equality. Okay, at the left, here is at right, c'est à droite, alors que moi je vais l'avoir à gauche. Donc je fais comment? So the derivative of v with respect of s is what? So now it is at left of the equality and is good. Okay, so I have negative fx, I have the derivative of v with respect to y, negative fy, and to finish the derivative of v with respect to z, which is what? Negative fz. Very, very good. So now I want to remind you the expression of fx, fy, and fz. Okay, so I will see it above. What is fx? Fx is 2x. Okay, fx, I will, well, it is 2x, and after that negative 2y z squared, and to finish negative 2z y squared. Copy and paste. Okay, I copy it and I pass it below. Okay, here, very good. So 2x for the first, so here is negative 2x now, because I have already a minus sign here. So moins fois moins, on dit que c'est plus, n'est-ce pas? Donc ça donne quoi? So you have 2yz squared. Okay, 2yz, and to finish is 2z y squared. It's very good now. So let's continue. Is very good. So what is the method? The method here is to take the first equation. Okay, I take the first equation. The first equation is the derivative of v with respect to x equal negative 2x. So with this expression, I will calculate v. It's a problem of primitivation. You know, I have the derivative and I want to find the primitive of the function, the given function. Okay, so v is the primitive of negative 2s. In another sense, what do you derivate? What do you derivate to obtain as a result, or as a result, negative 2x? It's simple. Is what? Is negative x squared, right? But don't forget to put a constant, because if you do a primitivation, okay, at high school, okay, in your last class, you know well how to primitivate a function. Okay, so here it is negative x squared plus a constant. Our constant is depend on y and z. Why I write c of y and z? I will explain it for you, to you. Ok, en fait ici vous voyez, c'est la dérive de v par rapport à ce qui fait moins de 10. Ok, donc v fait quoi? Moins carré plus une constante. Donc cette constante, ok, elle dépend de tout ce qui est constant. En fait, dans cette dérivée, sachez que is est la variable, is varie, et les autres, donc, the others are constant. Okay, les autres sont constantes en fait. Others are constants. Okay, so y and z, because the derivative is with respect to s, okay, the others or the other variables are constants. So it's normal to say that the constant c is depend on y and z. La constante dépend de y et z, parce que c'est y et z qui sont les constantes ici. Voilà l'idée. Very good. So if I finish to find v, what is the next step? Can I stop here and and say that the result is that, and je l'encadre et puis je dis que c'est ça le résultat? No, because I don't know what is c of yz. I don't know what is it. Okay, so I have to find c of y and z. Okay, so the method is what now? You replace your function. You replace the function v in the second equality. You know, here you have 1, 2, and 3 equalities. The function you find, you replace it in the second equality. Okay, so I will write the second equality is what? Derivative of v with respect to y, right, is equal to what? Is equal to 2yz squared. Okay, 2yz squared. Okay, so I replace, like I said previously, okay, I have to replace. It's a game, it's like a game. I have to replace, okay, v in this second equality of our system. So I will obtain what? The derivative with respect to y of what? Of the v I found. Okay, negative x squared plus c of yz, okay, equal to yz squared, to yz squared. So what is the derivative with respect to y of this expression? Okay, the variable here is y. Okay, now the derivative, so the derivative of x squared, okay, with respect to y is 0. So I obtain here 0 plus the derivative of c of y, which depends on y and z, okay, is equal to 2yz squared. So what is c? I said, remember previously, that c is gonna to be calculated, because I don't know it. I don't know what is c. Okay, the purpose here, or the goal, is to find c. Okay, so here I have the derivative of c with respect to y, which is equal to 2yz squared. So it is a problem of primitivation again, because I had a derivative and I want to say to find the function which is behind this derivative. Okay, so what is c of yz? Simple. I primitivate. So with respect to y, very important to know here. So because I derivate with respect to y, z squared is a constant. Okay, z squared is a constant. So I can give easily the primitive, or the primitive, excuse me, of 2y is y squared. Is y squared. Okay, so I write it here, y squared times z squared. Make sense? I think. But don't forget to put the constant. Don't forget. Never forget this again. Okay, so I have a constant. I will call it b. But b is okay. B depends on what? You say perhaps you say, or you think that b is depend on what? For example, x or y, or z. What is b depend on? Okay, here to know is very simple. Here y is the variable. Okay, y is the variable. So anything else is a constant here. But see, we don't have x here. We have only y and z, because c depends only on y and z. So I will not write that s is constant. No, here we don't have x anymore. We have only y and z, but y is the variable, and the second letter, or the second object z is a constant. Z is constant here. Okay, but don't confuse with the first one. The first one, okay, at the first step, okay, here we have 3 variables. Is just, I want to say v depends on x, y, and z. So here I have 3 variables, but x is the variable I choose. Okay, so the second, or the two, which the 2 y and z are necessarily constants. Okay, very good. Let's continue. C of yz is y squared z squared plus b of what? B of x. no b of z, because y is the variable as I explained it. Okay, y is the variable, so z is the constant, so b is depend on the constant z. Very good. Since I found c of y and z, I can replace it in the expression of v. Okay, because don't forget the final goal. The final goal is to find v. Okay, so I come here. Okay, I take v and I write it here. V, okay, is that. So if I replace c of yz in this expression, I have negative s squared plus y squared z squared plus b of z. This is the expression of the potential v. The potential v. Okay. Now, if you comprehend well the method, okay, this expression of v, I will replace it also in the shared condition, because remember, okay, that we have three equalities. Okay, we already use two of them. It rests one. Okay, so the final one, or the third one, is derivative of v with respect to z equal to zy squared. I will use it also. Then I replace the v I found in this. So I have derivative with respect to z of negative s squared plus y squared z squared plus b of z, okay, is equal to 2z y squared. Don't be confused. I just replace the v which is founded previously in this equality. Okay, so I have to derive to find, because b, I don't know b. What is b? Okay, now the goal, okay, is to find b here. Okay, let's derive this expression. Negative s squared with respect to z. Z is the variable here. Okay, so if z is the variable, okay, the derivative of s squared with respect to z is 0. Here, z squared, the derivative is 2y squared z plus b prime of z, because here I can write b prime without any problem, because b have only one variable. Okay, so what is the next step? The next step is to find b prime of z, which is, like you can say it, 2zy squared minus 2zy squared is 0. So I can say that b prime of z, because, or since b prime of z is 0, so b is okay, a constant. Okay, so I can write that b of z is equal to a. A is a real constant. Okay, then I can replace this expression of b of z in the expression of v. Okay, so I will replace it here, and I obtain finally the expression of v, which is equal to what? Negative s squared plus y squared z squared, if it's okay for you, plus a. A is a real constant, and I have the potential. Okay, do you comprehend the method? The method is very simple. Firstly, you write the expression. Okay, your vector is negative gradient of the potential, and you will have three equations. The first equation, you primitivate it, and you replace the result in the second one. After that, you replace also the result in the third one. It's very simple. Okay, but don't forget that when you do a primitivate, or when you primitivate a function, excuse me, okay, the constant depends. You have a constant, and here our constant can depend on y, on z, on or c or s, depending on the contents. Okay, it's very important to know that. Okay, if what how do you see my English? It's good. I know that I speak broken English, but that is not the problem. Okay, I have to speak. You have to speak also, because you have to improve every day. Bye bye.